The weekly schedule has both the names, both the course IDs. So I don't know what was the confusion earlier. Some of them were saying that, some of you were saying that only BAZG 523 is mentioned, and or maybe some other place it is mentioned like that. Uh, Maybe the WebEx has that. Okay. Okay, so next time onwards, you can please make note of it that BAZG 523 will be the other name for the same course. Okay, so whenever you see BAZG 523, it does mean that it is also same as CSIZG 523, same course. Okay, so we were discussing about some real life examples of data science where data science is used. So can you just quickly give some examples, the real life in which data science is used and how it is being used, or in what area is it being used. So weather forecasting is someone said, tsunami prediction, okay, stock prediction, Internet of Things, IoT, recommendation systems like on Netflix. In fact, that is one of the slides that I have, the recommendation system on Netflix or on e-commerce like Amazon. Churn prediction, the customer churn prediction, right? Whether customer will leave the service and till what time, what is the value of the customer, what is that called? The customer lifetime value, isn't it? Something like that. CLV, is it? Hospitals, as it is being used in hospitals in healthcare, right? Organizational statistics, uplink and downlink prediction, customers buying pattern, right? So, all right. So these are some of the quite a few examples that we have given. Let us discuss a few of them before we move on to the tools that we will be using in this semester and a brief overview of the tool. So recommender system, for example, the e-commerce website Amazon makes 35% of its revenue, of its entire revenue, from selling the products which have been recommended to the user. So you can see that it plays a big role in its overall revenue, right? Because customers buy 35% of the sales that Amazon make is from the products which have been recommended to the user. Okay, and the recommendation could be like based upon the user's own behavior. It could be depending upon the data from other users, similar users, like collaborative behavior or collaborative filtering as it is called, or it could be content filtering, which is just user based. And so even pricing based upon the user's earlier behavior or users buying pattern, Amazon may also change the pricing, right? You can see that sometimes the pricing is also changed for users. For different users, maybe like, I don't know whether it is different price might be shown to different users depending upon their patterns, their buying patterns. It is a possibility that some small changes in prices may be made if the commerce website thinks that it will result in more revenue. But anyway, the recommendation system works there. Okay, and also in Netflix, as someone mentioned earlier, the recommendation system on Netflix. Okay. So 75% of the users watch recommended movies. So it's a very big number. almost 3/4 of the recommended movies are actually watched by the users. So that means the algorithm behind the recommendation system in Netflix is quite good because it is able to find out the interest of the user by applying some machine learning or data science application algorithms in the background. Okay, so again the algorithm behind the Netflix will be very complex. Okay, it will be looking at a lot of parameters, hundreds of thousands of parameters. It may be related to the user. It will be related to the other users, which may have similar uh, watching habits or similar watching pattern. Okay, and depending upon what are the movies which are in demand at that time, a lot of such parameters will be there. But it is working because 75% of the users actually watch recommended movies, and people watch movies because they like them, right? So if they don't like, they will not watch. If they don't like the movies. Uh, so anyway, so it is working for Netflix, and the recommended system for Netflix is working better than for Amazon, right? But both of them are anyway recommended systems which are working. Any other recommended system that you are aware of apart from Netflix and Amazon, apart from e-commerce and movies? Any other recommended system apart from e-commerce and movies? All this. Is there any other place where recommendation might be used? Google search engine, banners, YouTube, YouTube, yeah. So YouTube videos, you may also like something like this, right? Or people also like IMDb job portal, right? So recommended jobs. Okay, in Indian context, you may have like, for example, Swiggy. Depending upon what you have bought earlier, what's in demand, what's in your neighborhood, it may also suggest some other cuisine or some other food stuff for you. Right? Air tickets. Okay, so recommended airlines. Right, there are entire websites which deal with this kind of thing. They recommend which one to buy, which is the best one. Hotels, tours. Okay, so these are all recommended systems. You recommend something to you, and then they will make money or they will get some users time. Ultimately, they have to make money, and once the users spend some time on that, they will earn money, right? Either from the ads or from some other way. Okay, things like logistics. Okay, the courier companies like FedEx, UPS, the big companies, they use data science to improve efficiency. So, as an example of how data science has helped there, uh, this the UPS company actually avoids left turns. So it's a US based company. Okay, so it is right side drive, right? So they avoid left turn because they found from all the analysis they have done that by avoiding left turns, they will save a lot of fuel, and ultimately they will save a lot of money. Okay, so they save 10 million gallons of fuel a year overall just by avoiding left turns whenever possible. Okay, if it is not at all possible to avoid left turn, then they will take left turn. But otherwise, even if it is a longer route, many times they will not take left turn and they will take the longer route. Okay, because they have found from different parameters and different algorithms applying data science that it might be there might be multiple reasons why taking left turn is bad. Maybe there are accidents involving left turns. Okay, because they are right hand drive, so they take left turn. Maybe the probability of accidents is more. Okay, so that is one of the major reason why they have taken this decision. But ultimately, they have come to this conclusion, and they are able to show it that they have actually saved this much fuel. So another one is dynamic pricing, or the surge pricing, as it's called in Uber. I don't know what it's called in Ola. What is called in Ola? Is it dynamic pricing or surge there also? But I think in Uber it's called surge pricing. So depending upon if there is a lot of more demand than supply, if there are more people who want to travel, take a cab, then there are actually cabs available online. Then the surge pricing takes place, and the company, or the Uber company or the Ola company, they will send more drivers to those locations where there is more demand, but they will charge more from the user, right? So they will get you to the point you want, or they will get you a cab, provided you are willing to pay more money. Okay, so that is the demand and supply involved in action there. Right? So if it's important to you, you will travel. Otherwise, if you find that you can travel later, you just cancel. So surge pricing is for that. If it's important enough for you, you will go there anyway, even if it is 5 times more pricing, right? So in Uber, for example, you look at how data science is used. They analyze the short-term effects of surge pricing on customer demand. Okay, so whether the customers' demand can be met by surge pricing, whether customers are willing to pay increased price, increased fare to reach their destination. Okay, now so they will analyze the long-term effect, whether customers will leave, will they uninstall the app, because when it was important for them late night from the airport, maybe they got very high pricing and they instead took some local cab, and they found that it is easier to use the local cab. So there's kind of long time effect where users may simply uninstall the application and they want to use it, whether that happens more or whether they are actually benefiting from surge prices. Okay, so this kind of analysis on the backside is also done at these companies, and some regression analysis and all these things to get more drivers to the neighborhoods which will be more crowded, which are more busy. Maybe there are more companies in some certain locations, okay, or maybe that there's a particular route that people take at a certain point of time, so that more cabs should be sent there at that point of time. And Uber actually announced some time back that they will not be using surge pricing in the future. Instead of that, they will send more drivers from the beginning itself. They will route them in such a way that they will be available, and they will be able to. So they will apply these machine learning algorithms to send more vehicles before the supply exceeds before the demand exceeds the supply. So their surge pricing will not take effect. So in Uber, actually, they use tool like they use Python very heavily, along with other libraries, which are Python libraries which do some specific stuff. NumPy, SciPy, Matplotlib, Pandas, okay, Scikit-learn. These are all libraries which are for Python, which will make Python do a lot of machine learning and data science stuff. It's also used in manufacturing industry. For example, the GE, it uses data science to predict defects, in which part defects are more likely. Okay, so that it can concentrate or can focus on that area, and ultimately it will reduce the cost of production. Okay. So there are a lot of things, so almost in every area, area today, data science is being used. Okay, I think it's very quiet in the chat box. Are you listening? Am I audible? Okay, okay, all right, okay, right. Okay, so these are some of the examples where data science is being used. Okay, and we can see that. And apart from this, I've already explained one of the examples that the healthcare industry, how the app, for example, that can actually predict the mental condition of a person just by his uh, mobile usage, how the pattern that he is following using the mobile. It will just collect data and predict the mental condition, and so that, and it is especially true for the condition for the people who have already suffering from say stress conditions, so that the doctors who are ultimately treating those get this information, so that they will get this input and they will quickly may recommend some medicines or something as needed, or they will take some action. Okay, now there's a question. Can we say in older days when people said will rain on that day or not, is that data science? What do you say? What do other students say? Some person says will it rain or will it not rain? Is that data science or not data science? Okay. And if it is data science, how is it data? How is it data science? What is the data they are using? So remember that for data science, ultimately there must be data that is backing up your prediction. Okay, you must have certain set of algorithms that you are applying on that data. Based upon that only you can say, okay, I have applied done this on this data, and you should show that this data is relevant. Okay, what is the algorithm that you are applying, and because of that you have got this result. But if someone just says because of sixth sense it will rain or not rain, okay, then it's not data science, right? Yeah, but if someone looks at different patterns, maybe someone says I can look at the way the animals are moving around, right, and then they can predict exactly where rain will come, at what time will rain come. Then maybe they are doing some analysis. We can say it is data science, but there is some logic behind that, right? But still, it is not data science. It is rather intuition that they are using, or they are using past intuition to deduct that okay, something will happen. Okay, now let us see what you will learn in this course. Okay, now because there is a lot of overlap of this course with statistics that you are taking or you have already taken, a data mining course that you are doing in this semester. So are all of you doing data science course in this semester, data mining course in this semester? So CSI ZZ523. So have you already done this course, or are you going to do this course sometime? Okay, so CSI students do not have statistics or data mining. What is full form of CSI? CSI is for computer science, computing system and infrastructure. Okay. Okay, and BA is for business analytics, is it? BA. Okay. So seems like a lot of you will not have data mining course, so we will have to take a lot of examples from data mining. Okay, anyway we will take those examples. So those who are already doing this course in this semester, they will benefit as they will get double the practice. Okay, those who are not taking data science or who don't have this data science course in this semester, they will learn about it. Okay, so I will cover everything from the basic so that all of you can come to equal terms. And machine learning, of course, none of you, both the courses are not doing. Okay, so but machine learning, the algorithms, what is the mathematics behind machine learning, that we will not study anyway. So the data mining part is important here. So to differentiate the learning and make it the course fruitful to you, as someone already suggested earlier, and I had that in mind anyway. So we'll have more hands-on data science. Okay, using one of the popular and powerful tools. Okay, and we will take some real-life examples and case studies whenever possible. It is not possible to take those big examples and real-life case studies in contact hours, but we will take some for the assignment, or I will try to take some during the course also, during the contact hour also. The real-life examples are not very big, and we can work on that. We can work on them during the time available to us. Okay, so this will be the focus. Okay, now I have not yet mentioned what tool we use. So how many of you are comfortable with or have worked on R before? R tool. Not worked at all. Never worked. Okay. Okay. How many of you have used or learned Python? Basic knowledge. Okay. So someone has a lot of experience in Python. So I think it seems like more people have used Python than R. Is it? Okay. So okay. So among those who have used either of them, it seems like more have used Python. Okay. Many of you have not used either of them, so that is fine. But among the students who have used either R or Python or both, it seems there are more number of users who have used Python. It seems from the answer from the chat. Okay, that's good. No problem. Okay, so we'll be using Python in this course. So why we are using Python in this course is because it's very easy to learn for beginners who have not used any programming language as compared to R. Okay, we used R in the last semester and there was a lot of problem with the students. Okay, it is not very intuitive to learn as Python. R is not as intuitive to learn as Python is. Okay, so Python is quite easy to learn. I will show some of the examples. Those who have not used Python earlier or have used some other programming languages, how easy Python is, or the libraries in Python are to use. So we'll only be using Python in this course. Okay. Another reason to learn Python apart from it being easy is that it's very powerful and general purpose. Okay, so while R can be used only for data analysis, working with data, Python is a general purpose programming language. You can write any kind of program using Python. Okay, you can write any kind of application or program. And also, it is getting more and more traction in the industry. It is heavily used and supported in data science community. So you get an answer immediately if you ask any question in any forum online. Okay, whether it is Stack Overflow, Stack Exchange. Okay, if you ask something related to Python or its libraries, you'll get very quick answers. Okay, and it's also it's used in industry quite a lot. And in fact, it has just overtaken R. Okay, to become the leader in data science and machine learning platforms last year. Okay, so still last year it was R, which was having was more popular than Python, but a couple of years back Python overtook R, and now this time and this year's the poll in KD Nuggets. So this is all the KD Nuggets poll. I can see here KD Nuggets. It's showing that it was actually headlined Python is eating away R. Okay, so Python is gaining at the expense of R. You can see that Python is kind of steaming ahead. More than 10 to 15% more users are now using Python. So it is more and more people are using Python. Okay, and if you look at other software that people are using apart from Python, you'll see that a lot of them are actually related to Python only. If you look at Anaconda, people use Anaconda for Python. Use Scikit-learn is the library of Python. Okay, Keras again it is used on top of Python. Okay, so a lot of these are related to Python. Keras is for deep learning. Okay, so Python is it's like reading English. So Python, reading Python code or understanding Python code is very easy. It's not like R. Okay, so even if you have to learn R for some other course, learn it. But for this course, you'll be using Python because it's quite easy. Okay, I'll show you how easy it is just in a second. Okay, remaining are all proprietary, so I'll not be using. So these two are open source. So these two are the only option. But R, I found that it was not intuitive for the students in the last semester. I tried with R, but it was not as interesting as Python will be. Okay, you can do a lot with Python and its library. Libraries. All right, so what we will be using is Python and its libraries. So the libraries are like they are called NumPy, SciPy, Pandas, Scikit-learn, Matplotlib. So all these are different libraries that we'll be using as needed. Okay, but they're all some packages. They are nothing but packages. You just have to use the packages, use the APIs which are available in those packages. Okay, I'll show you some examples in the next slides. And the distribution of Python that we'll be using is Anaconda. Okay, so Anaconda is kind of it takes everything together: Python, R, NumPy, SciPy, everything, all the machine learning stuff together, and gives you a single distribution, Anaconda. Okay, so and you don't have to install. If you just install Python, then you have to install all the libraries separately. Why not get it at a single place? So Anaconda provides you everything as a single package, as a single software, in a single place. Okay, so you'll get whatever notebooks, IDE, whatever you want by just installing a single software, Anaconda. So just for this course, I'll be using Python 2.7. That's what I've been using. I'm more comfortable with Python 2.7. I have not yet moved on to Python 3. Okay, so the Anaconda is just a distribution. Okay, it's just a distribution. It means it's a collection of software, multiple softwares. Okay, so instead of installing Python, NumPy, SciPy separately, and then trying to make them work together, Anaconda provides them all at the same place. So once you install Anaconda, you are installing everything together. Okay, so you can say it's a collection of all the Python and its libraries, all the machine learning utilities. Okay, and it's better if you use Python 2.7 because that is what we will be using. Because many of the constructs in Python 2.7 will not work in Python 3. So for example, just print statement will itself not work. So Python 2.7 is very easy to work with. Okay. Yeah, so those who are not from programming background, okay, that's why I given this very simple tool here, simple distribution, Anaconda. Okay, so just go to this download location. Okay, and just download it for your system. Okay, I think all of you are on Windows, right? or you have Windows working. So it is available for Windows as well as for Linux, Unix distribution, Mac. So download it for your distribution, your system. I just downloaded Anaconda on this system in the Will Studio in this office. Okay. So Jupyter, I think it is also available in Anaconda. Okay, Jupyter Notebook is also available in the Anaconda distribution. Let me just check. But you won't be needing Jupyter. Don't worry. So don't worry about that. Yeah, so it's available already. Yeah, Anaconda also provides R. Yes. Okay, but I have not used it for R. I have only used it for Python. Okay, so I'm not sure how it works for R. Yeah, you don't need to install anything else. Just install Anaconda and you are done. Okay, you'll get everything you need for this course. Just install this simple Anaconda 2. Okay, there is Anaconda 2 and Anaconda 3. Download Anaconda 2, and you'll get everything you need, all the libraries, everything in a single place. Okay, so skip if it is asking for any cheat sheet or anything, just skip it. Okay. Okay. So Python 2.7 is the latest version for Python 2. Okay, Python 3 is different. Don't worry about that. Now don't go into details of what Python 3 has. So Python 3 is a different version than Python 2. For Python 2, Python 2.7 is the latest one, and most of the places Python 2.7 is still being used. So don't worry about it being old or some old version. Okay, it's relevant. Do you mean Python 3 is not used in data science? No, I don't mean that. Okay, I'm only saying that Python 2 is still being used a lot, so don't worry about that. Okay, it is still being used and it will be supported till 2020. So don't worry about that. At least you have 2 years to use Python 2.7. And once you learn about Python 2.7, then going to Python 3 will not be difficult. So there's only some minor issues, minor compatibility issues. Okay, can you suggest some good book for Python? Right now I don't have, but just let's discuss this on the forum, discussion forum. Okay, we'll discuss that. But most of the stuff in Python it's available online. Okay, the books and all, they are mostly open source, so you can just download them and use one of them that is that you find easy to use. Okay, so once you download Anaconda 2, so it has some IDE like Spider and all, but for quick run, I mostly prefer IDLE. Okay, it has a option called IDLE. It has a IDE called IDLE, Integrated Development Environment. So IDLE, IDLE, and the location for that most likely will be wherever you have downloaded Anaconda. Okay, in Anaconda, maybe Anaconda 2. Let me just check. Anaconda 2. Okay, in Anaconda folder we have downloaded Anaconda. In that you'll have a folder called lib. Okay, in that you have another folder inside lib you'll have another folder called idle lib. Idle lib. Inside idle lib, I'll just send it to you. Don't worry, the path to the idle environment, and inside that you'll have idle.batch. Yeah. Idle.batch or the idle batch file. Okay. So what you can see, I've just sent it. So you can see that this is the location for the idle IDE that is available when you install this Anaconda Anaconda. When the installation is over, don't wait till take some time to install. This is just to note down this location. So you can just right click on this particular batch file called idle. It will just be called idle. It will be shown as a batch file. Or right click and just send it to your desktop or wherever you want to, from wherever you want to run it. Okay, so you can just have to double click later on to start idle. Okay, so it will just you'll be able to run idle from there. Okay, now what I'll do is I will just share my desktop and show you some of the basic things that you can do with by using Python, and what are those other libraries, some of these libraries, small ones like NumPy and SciPy, Pandas, and what we do with these. Okay, what are they useful for? All right. So just now, I'll just share the screen. So are you all able to see the screen? Okay, good. So when you right click and send the desktop shortcut, that idle as a shortcut, you'll get something like this. Are you able to see the idle shortcut here? Yeah. So just have to double click it and it will open the IDE for you. Okay. So something like this will open up for you. Okay. And this you can type any program that you want. And this is just an IDE, just an editor. Okay. So let us see what kind of programs you can write. So let's say I want to just print hello world as a conventional or traditional way of doing. So I just want to print hello world on the screen. Okay, so print. So that is the command that is given to Python to print hello world on my screen. Okay, then I'll just save the file and run it. Okay, so Control S will save it. Save. Okay. So I run Python with only 2 GB RAM. So I think that is the minimum we have anyway, right nowadays. So 2 GB is enough. Now once you save the file, you can just press F5, the F5 key on top, or you can use run from here, run module. Okay, F5, or you can see the shortcut is F5 here. It will show you the output, and the output is shown right here, hello world, right? So it's as easy. So writing program in Python, you can see it's very easy. You just have to just give the instruction what you want to do, and it will do it for you. Okay, let's just to show that it is actually changing whatever you are doing. You can just make some modification, make a proper English, save it, Control S, and then press F5. It is printing the new string right here. Okay, hello world. So this is the basic thing that you can do using Python. If you want to save some variable, save some value in a variable x, it will automatically find out what kind of value it is. So let's say x is equal to 5, we have saved as, and then you want to print the value of x. Let us comment this out, whatever you written earlier. So the hash is used for single line comments. So everything after hash character is taken as a comment for that line. Yeah, so every time you make a change, you have to save, Control S. So save and run F5. Okay, you can see that the value of 5 is printed because x value was 5. Okay. Or you can also print the value of some other operation that you can do on different variables. So here, for example, y is equal to 10 is another variable. You want to print the sum of x and y. Okay, and we can see that 15 is printed. So that is, so these are some basic examples. Okay, so let me just save it as save as. Let me call it as contact hour 1 or contact hour hello. Okay, so this file is saved as contact hour hello in the desktop. Okay, on the desktop. Now let us say I want to print this file. I want to print on the screen whatever the content of this file. So the content itself you can print. So let us comment all them out. So this triple quotes or 3 quotes starting and ending. So anything in between is taken as the multi-line comment. Okay, so 3 single quotes or 3 double quotes. So single quotes and double quotes, they are kind of interchangeable in Python. Either you use either single quotes or double quotes. Okay, but they should be matching. If we are using single quotes, just use single quote at the beginning and end. So these are multi-line comments, so they will not be interpreted by the. They will not be run. This instructions will not be run by the interpreter. Okay. Okay, there is a question: can we use Python on Excel files? Yes, we can use Python anywhere. Okay, Excel file will be if you save that as a CSV, just save Excel file as CSV, or maybe there's some utility that you can use. Okay, if you have a way to read their Excel file, you can use that Python on the Excel. Okay, the best way is to save them as CSV file, comma separated values. Then you can use that. Okay, so let us say you want to open this file, that is hello ch-hello.py. So remember that .py is the extension for Python files. Okay, so the best way to do this is with open. So this will take care of closing the file whenever you are done with this particular thing. So with open, what file you want to open is ch-hello.py. Okay, so you just want to read it, so you don't need to give any mode, and you want to give it some name. So let's call it input file. Okay, and then colon at the end. So you are opening this ch-hello.py, that is the current file itself as a text file. You want to open it so that you can read it. Okay, you can read the content of that file, and the handle you are giving to this file is env. Okay. Then one thing that Python is very strict about is the indentation. Okay, there is a gap after this, so leave a gap of 4 spaces. That is the traditional way. Okay, so anything that is part of this with statement, that while you are opening this file, what you want to do with this, so they should all be aligned properly after 4 spaces. Okay, so we'll open this file as env. What you want to do is you want to read, let's line by line, and then print them one by one. Okay, until you have something remaining in the file. So let us say you want to print line by line. Okay, so first of all, let's say line. So something you will save in line, in a variable called line. You are saving the first line. So what you want to read? You want to read the file, and the file is now available as this handle in f. Okay, so in f dot read line. Okay, so this is a function. You can see that in f dot read line means read a line from this inf file. In f dot read line. Okay, and just check whether line length of the line is greater than 0 or not. So I'm making this very explicit. If length of line is greater than 0 means you have a line available. So you can see that here after while loop, automatically when you press enter, this code is automatically indented. So this idle has automatically indented the code for you 4 spaces after while. Okay, so you have to maintain this kind of indentation. So while length line is greater than 0, what do you want to print? You want to print the line, the value of line, this line. You can call it any other name. So let's call it L, just so that it is clear that you can use any name. You can just print the name, print the line, as well as then after printing the line again read the next line. So it's kind of, once it reads the line, immediately go to the next line. Okay, so it will read line by line. Once it reads a line, the pointer or the file pointer will move to the next line, and you can just keep on reading. So L is in inf dot read line will again read next line. Okay, and the while loop. I think all of you are aware of while loop, right? So while this condition is true, this loop will continue running. So L is equal to inf dot read line. So if the okay, it should be L here, not line now. I changed the name. So if the length of this line that you read here is greater than L, again it will print that and go to next line. Okay, now after that you have 2 kind of comments. One is multiple line comments and one is single line comment, which will not be printed. Nothing will be done on this. They are just discarded by the interpreter. Okay, so let us see whether it works or not. So save the file and print it, and you can see that a lot of this stuff. Okay, there was something already there, so I just delete everything. Okay, let us run it, and you can see that it is printed. Okay, so after print statement, automatically a new line is entered. It's automatically printed. So if you don't want the new line to be printed, you can just put a comma after print statement and save file, and you'll see that now only the lines which are available in the file itself will be printed. By itself, the print statement will not put a new line. Okay, so you can see that this was the file, right? This is your file. So you are printing the file itself. Yes, print just means output whatever you next you are giving it to you. So print L will print whatever L contains, whatever the value of L. Printing means printing on the screen. It will just output on the screen. Okay, there's a question. So what about language like Java? No. In data science, Java is nowhere in data science. Don't use data science. Java. Okay. Three code means printing. You means print out. If it is printing of what? If they are blank line, will this code will work? Print means text output. Yes, text output. Okay. And whatever is inside this double quotes or inside these comments, they are all discarded by the Python interpreter. So they are not this code inside triple quotes or after hash. They are all discarded. They are all not taken care of. Okay. So what is the use of with open? So after this happens, suppose you are done. Okay, now you go to this line and you do something else. Let's say you print hello or done. Let's say you are printing just done. Okay, so at this point of time when you are out of this with, now here you are out of it. So this file that you opened will be automatically closed. Okay, so with statement here, it is useful because you don't have to worry about closing the file. It will be closed automatically once you come out of the with that come out of this with the statement here. Okay, so the file closing is automatically taken care of, and you can see that the new modified code is now printed and it's also there. Okay, so the comma in print is just not printing in a new line. Okay, so it's only printing whatever is in the program. So now in the program itself we have a new line. After println, you can see that in the text itself you have a new line. Right, so it will only print that new line. Don't print any extra new line. Otherwise, as you saw earlier, it will println after println, a new line is automatically printed. It's like this. Okay, there is extra line after every line. There is extra blank line. Okay, so this is a very basic example of just using Python. And similarly, you have utilities like you have libraries like NumPy. It's for using with arrays and matrices. Okay, so let us use NumPy now. So again, before using NumPy, let us just put them all inside triple quotes to comment them out. You don't want to use these quotes later again. So to use these libraries, you have to import them. Okay, import means just include those. Okay, import statements should be on top before you use them. We use the libraries. So import NumPy as NP because you don't want to type NumPy. So shortcut from that is NP. Okay, mostly people use NP, but you can use any name. But NP is the common conventional name for NP and NumPy because that NP looks like shortcut for NumPy, right? So import NumPy as NP. So whenever you want to use NumPy, instead of that you write NP. Okay. So once you write this libraries, so NumPy is a library for matrices and arrays. When you want to do fast computation, okay, it is a library that has code that does very fast computation of arrays and matrices. Okay, so scientific application in which you have like say thousands or millions of million sized arrays. Okay, if you have say 1000 by 50,000 size matrix or array. So in that case, NumPy provides a very fast library. So NumPy is a very fast library for manipulating those arrays or to work with those arrays. Okay, yeah. If you want this to be shared, I can share this as well. This file that we are writing this code in. That's fine. Okay. So import NumPy as NP. So this will make this NumPy library available to this program. Okay, just to make this library available to this program. Now suppose you want to create an array, a NumPy array. Okay, so in that case you will use np dot array. Okay, and then the array itself. So array, remember that in Python or NumPy, in Python it's called list. In NumPy it is array numbers. So let's give them some values. The array has some values. Let's say 1, 2, 3, 4. Very basic. So they are comma separated always. And then you want to print the array. Okay, and you can see that the array is printed here, right? One, two, three, four is the array that you had put here. Just to show you that it is indeed your array that is getting printed. What you can do is just let's say some value. Let's say make it 40. 1, 2, 3, and 40. Save it and run it again. You see that the new array is getting printed now. Okay, you can print the type of any data. So let's say you want to see what kind of type it is. What is array's type? Okay, so again you can print the type of the array. So here you can see that this printing type is numpy ND array. Okay, that means it is a numpy array. You can also convert it to normal Python list. In Python it's called list. Okay, so how do you convert it to a list? You can just type dot to list. That is, let us say print. Let's say you want to convert this array to list and then print its type. Okay. And you can see that the type is to list. You can also save it somewhere before doing this. Let us save it to some say array. Let's say Python array p array is equal to array to list. Just to tell you that it is Python array, and then you want to print the type of p array. Okay, so it is list. So in Python it is called list, but in NumPy it's called array, ND array. Okay. So you can perform all these very fast. So let's say you even want to work with the Python array itself, and let's see what some of the capabilities that it has that plain Python doesn't provide. What is the use of this? So let's say you want to multiply each of the numbers by say 10. So just have to write into 10. It's called broadcasting. So it will automatically multiply each of the numbers in the array by 10. Each of the numbers. So array into 10 will multiply each of the numbers by 10. And you can see the output. Indeed, each of the numbers has been multiplied by 10 when you multiply array into 10 and printed the output. Right. So print array into 10 will multiply your number by 10 and print the output. Right. So it is doing the broadcasting. And let's say you have another array called array2. Okay, and that's also a NumPy array. With some different set of values. Let's say the values here are 4, 12, 30, and say 25, say 50. Okay, so this is another array, array2. And now let's say you want to multiply individual elements of the array of these two arrays. So that is you want to multiply 4 with one corresponding element. So first element, then second element, third element. So again, the NumPy is very intuitive here. Just write array into array2, and it will know that you want to multiply the individual elements, first element, then second element, third element, and you want to print the output. And that is what it is doing. You can see that the output is indeed like that. The first element is multiplied, 4 into 1 is 4. Then second elements are multiplied, 24. Then third element, and then fourth element, right? Okay, there are some chats. Let's check. Yeah, if Anaconda is downloaded, NumPy and Python and Panda and all other libraries are by default download. You don't have to do anything else. Just download Anaconda, install it. Okay, everything will be installed. Okay, so So these are just some of the examples. Now let's look at something that we have been using, some correlation, right? So all of you know about Python, this Pearson correlation, right? So this kind of API is actually provided in SciPy dot stats. Okay, so this stats is the module in the SciPy library which provide this, and let's say we are importing it to use, and we are just calling it ST shortcut. Okay. So these statistical modules are all in SciPy.stats. It provides a lot of those modules. Okay. And Pearson correlation is there in that module. Okay. So if you're not getting all, don't worry. It is just to show you what you can do, what are the things you can do very easily in Python. Okay. You don't have to learn all this today. You'll have a lot of time to learn it. Okay. Yes, array 1 into array 2. Array 1, there is no array 1, array, ARR. Okay, let's call it, if you want to call it array 1, we can call it array 1 like this. Okay, now suppose you want to find whether these two are correlated, or what is the Pearson correlation coefficient. I think all of you know what is Pearson correlation, right? Whether the two are have some correlation, whether you are increasing or decreasing. Okay, while the other is increasing or decreasing. Whether if they are both increasing, yes, R, small r. If they are both increasing while the other is also increasing, then it's a positive correlation, very high. Okay, let's, in this case, what do you think will be the correlation? Let's print the correlation. Print ST, because ST is the module that you have imported from SciPy stats, right? ST SciPy.stats you imported as ST, and the API available for Pearson is just called Pearson R. R is for correlation. And in this case, you want to find Pearson R of array 1 and array 2. Is that? It will give you the R value and the P value. Right. So here you can see the output. So this is the first is the R value, and the second one is the P value. So R value is quite high, 0.86, but P value is not very significant, it's 0.13. Okay. If you look at the 95% confidence interval, it is not very significant, 0.13. Okay, so we will continue with this session. Whatever we left out, I'll give you some more examples of how Python can be used. Okay, in the next session. Thank you very much. So because there is one more class that you have to attend. Yes, we have a class 2 to 4. Just check the schedule. Most likely we have a class tomorrow. Okay, thank you. Okay, that's good. Enjoy the session.